Okay, I call this the not the 27 card trick. And that's because there's a classic 27 card trick, but this is not it. This is a card effect that I designed last night. And I do want to point out that the only information you need to remember is the sequence 7654. Okay, so right here. So if you can just hold on to those four numbers, 7654, you'll be able to perform this. Now, I do also need to point out that this is a probabilistic effect, meaning it's not deterministic. There is a probability of it not working, but it is the case that there's better than a 95% chance that it will succeed. Okay, and so let's see if we hit one of the 95 out of 100 times that it would normally succeed. Okay, so what we need for this is 27 random cards. Okay, so 1, 2, 3, 4, 10, 20, 27 random cards. You can have the spectator actually choose those, but they need to be random. Okay, so 7 in the sequence 7654. What does 7 refer to? It's a claim that there's at least 7 cards of the same suit. Now, there may be more than 7 cards of the same suit or multiple groups of 7 cards or more of the same suit, but there's got to be at least one. So as you look at the cards, can you see a suit for which there's at least 7 cards? Well, I think so. Here I can see, and there may be others, 2 clubs, one more there, 3, 4, 5, hope I saw it right, 6, 7, there we go. So we got 7 clubs, very good, we'll put them right there. Okay, so we're going to go on to 6. So we're predicting that there'll be at least 6 cards of the same suit, but it needs to be hearts, spades, or diamonds. Okay, so can we find 6 or more cards of one of the other suits? Well, it looks like hearts might be a good choice. 1, 2, 3, 4, 5. I just need one more here. Oh, right there, we got one. With one to spare, but we got 6. Let's just double check. Okay, so 6 hearts. Very good. Going on to 5. There should be at least 5 cards of spades or diamonds. Those are the ones that are left. Do you see 5 spades or 5 diamonds? I think I see 5 spades. So you get a 2 there, and then 2 more here. There you go, 5 spades. We're doing great. We just need to get down to 4 here, and then we will have succeeded at our prediction. Okay, and then we can go on to the bonus phase. If we're that lucky, we might succeed at that as well. Okay. So we're looking for 4. Now we have clubs, hearts, and then diamonds, so we need at least 4 spades. Do we have at least 4 spades? Let's see, 3 there, and then 1 more there. We do indeed. Okay, so we succeeded at the main prediction. Okay, so that is the principal prediction that we made, and it happened. It wasn't guaranteed to happen, but there's a very good chance it would happen. Okay, and then if we want to go on to the bonus, is it true that there's 3 of one of the 4 suits? Well, it doesn't look like it. We get 2 diamonds, a club, a heart, and a spade. Okay, so we won at the principal routine here. It didn't quite get the bonus phase to work for us. Why don't we do that one more time and see, maybe we'll be luckier and actually get this as well. Okay, but I do need to warn you, there is a probability that we won't even succeed here. It's less than 5% chance, but a 5% chance is not 0. So there is a small chance that we'll fail at steps 1, 2, 3, 4 here. Okay, so you mix the cards really well. Okay, have the spectator do that, and then they can deal out 27 cards. 1, 2, 3, 4, 5, 10, 20, 27 cards. Okay, so we need to find at least 7 cards of the same suit. Okay, and do we see, oh, let's not go off the camera view here. That's a club up there, just so you can see. Then way down here is a club. Can you see 7 of the same suit? I think clubs might work, but I think it barely works. Whoop, I don't want that one. 1, 2, 3, 4, 5, 6, 7. We did it. We found 7 clubs. Perfect. Okay. So we succeeded at that little first step there. I'm going to slide these over. Okay, now we need 6 of either hearts, spades, or diamonds. Do we have at least 6 of those? Well, let's find out. Well, I think we have at least 6 spades, probably more than that. So 2, 3, 4, 5, 6. Spades, perfect. Okay, now we're looking for at least 5 of hearts or diamonds, okay, to be successful in our prediction. 5 of hearts or diamonds. I think there's 5 diamonds for sure. So we have 3, 4, and then 5. There we go. We got 5 diamonds. Very good. And now to finish reaching our minimal goal here of 7654, we need 4 hearts. Do we have at least 4 hearts? Okay. So 1, 2, 3, 4. We do indeed. Okay. And I do want to point out that you can fail. This can fail. There's a 5% chance. And the many times that I've played it, I have witnessed it not working. It's not very often, but it can happen. Okay. And then, should we go on to the bonus? Are there 3 cards of the same suit in the remaining cards? Oh, we did it. We did it. We did it. We did it. There's 3 diamonds. Okay. And then let me just point out something that I have gotten to work a number of times, but it's pretty rare. Not only have I gotten 7, 6, 5, 4, and 3, I actually got the last 2 to be of the same suit. That has, in fact, happened. I haven't calculated the probability for it, but it's probably very small. But I've seen it happen twice in the many times that I've played with this. So it does happen. Achieving the 3 here happens more often than getting all of these to work out, but not every time. Remember, the first time we went through this, we didn't get a set of 3 here at that stage, but it can happen. And then if you're super lucky, you get the final 2 to be of the same suit. So play with that. It's a fun effect. Let me just tell you what it's based on. It's partially based on something called the pigeonhole principle. Now, I need to make it very clear here that only this first goal here of 7 cards of the same suit, that is the only one that's guaranteed by the pigeonhole principle. The others are not. Okay, so the remaining ones of 6, 5, 4, 3, and especially 2 are probabilistic. It's very likely to happen for 6, 5, 4, less likely to get the 3 as well, and far less likely to get the final 2 to be of the same suit, but it is possible. So anyway, I thought this is kind of a fun little activity. It uses the pigeonhole principle, and my calculation for the probabilities relies on applying the pigeonhole principle even to these and comparing it to the degree to which we move beyond the promised quantities here. But let me just tell you what the guaranteed numbers are for the pigeonhole principle. You're guaranteed to have a 5 where I have a 6. You're guaranteed to have a 4 where I have a 5. You're guaranteed to have a 3 where I have a 4. Okay, so I pushed it one beyond what we're guaranteed to happen by the pigeonhole principle, which moves it into the realm of probability. Okay, so it's not guaranteed, but in this case, very likely that you'll achieve these 4. Like I said, a little less likely that you'll get that, and then far less likely that you'll get the two final cards to be the same suit. So anyway, play with that. In fact, if you're familiar with the pigeonhole principle, try it out. Do the calculations yourself and see where it's being used in this routine and where I deviated from it in a way that still allows me to calculate probabilities for these non-guaranteed quantities of 6, 5, 4, and of course 3 and 2 are not guaranteed either. Okay, so thank you for watching, and take a look at other videos on the Absolute Math Magic channel.